All right, guys, we're going to do one more example, and this time this is with a density graph. We use density a lot in chemistry because it's one of our key identifying factors for substances. A lot of times we can take an unknown substance and based off its density determine what that substance is. So we're going to do the same thing. So we're going to take our tabulated data, so our volumes and our mass that we measured in the lab, and we are going to plot it and determine density and determine a relationship between the variable of volume and mass. So the first thing you always want to do is draw the graph. So I didn't actually draw it. I don't want to take the time in the lecture to draw it. So I already have it pre-drawn here on the slide. But make sure you guys understand how to plot points on a graph. All right, the next big thing after you've drawn the graph is to make sure that, well, first off, before we move on, make sure that you can understand that in any type of tabulated data, you can easily always determine your X and a Y, whether you're in the lab and you created it or whether you are getting data from somebody else. Your X will always be the first column. Your Y will always be the second column. Now, as kind of trivial as that seems, I have a lot of people who miss that. So your X is always first. Remember, your X is your independent variable. So that's the variable that we went in the lab and we manipulated. So in this case, I went into the lab and I manipulated the volume of the substance. So I manipulated the volume, and this was actually of isopropanol. Isopropanol, you guys know, is rubbing alcohol. So I put it in a graduated cylinder and I manipulated the amount, the volume of the substance in the graduated cylinder, and then I weighed it. And so this was my result. So this was my dependent. I went in and I measured the responding, the weight or mass of the object. And then we plotted it. Now, what you're going to do after you've plotted your scatter point is you're going to draw a line of best fit. I'm going to show you in a couple slides how you can do this on your device, but I also want to make sure you can do it by hand. When you're drawing a line of best fit, you're going to want to try to get as many plots on the line as possible, and you're also going to want to make sure you have the same number of plots above as you do below, because you want a true average. So I'm going to draw one here, and you always want to go through 0. Okay, so we should always have the line go through 0, 0. All right, so I'm going to go here, and I have my line. So there's my line of best fit. If I had more data points, I would probably have more above and the same amount of below, but this is a pretty good average here. If you ever have plots that are way off, so let's say I had a plot that was way over here or way down here, those are called outliers, and those are data points that we usually throw off because they just have way too much error in them. So something went wrong with the lab and they're not really true values for the calculation. All right, so that's the first step. Taking your tabulated data and drawing a graph and then giving it a line of best fit.